Hi, everybody. It's Mr. Dahl again. You have a substitute there with you right now if you're in class, or maybe you're viewing this at home. But either way, we're going to continue in the notes that we started earlier about heredity. Now, thus far, what we've talked about with heredity, we've discussed that it's the passing of traits from parent to offspring. We've talked about inherited traits, and we've talked about acquired traits. We did some practice problems where we decided if things are inherited or acquired. And then yesterday, you should have done this little activity with whoever was subbing in the class, or if you did it at home, where we looked at this pair of genes and we imagined that they had inherited and acquired traits, and we tried to come up with what those might be. Now, as we're talking about inherited traits, I want you to look at this diagram right here. So as you can see, we have this diagram. It's a family tree. And maybe the substitute would want to pause this and discuss what we're seeing here. And if so, feel free to have that discussion. Then you can skip my discussion if you'd rather have it in person. But essentially, you see the original parents at the top, up here, and they have how many kids? Well, you might think 8, but actually it's 6, right? These ones connected by the line are their children. And these ones here and here on the edges are the ones who marry into the family. Now, there's also a color code. What does the blue person mean? Well, if they're colored blue, it means that there's some disease present. I want you, with the substitute, to, if you could pause this video for just a second and just brainstorm some potential diseases that you can have a family history of. Gather some ideas from the class and discuss what are some diseases that could be passed down in your DNA. Go ahead and pause now. All right, so you have discussed some of those diseases. Things like maybe you mentioned heart disease, or maybe you mentioned certain types of cancers, and those are great. Some of those diseases can be acquired as well. Let's talk about diabetes. Let's imagine that this family here has a history of diabetes, and the blue person means, well, they have diabetes, and if they have that tannish color, it means that they don't have diabetes. Now, we're specifically talking about type 1 diabetes. There's actually 2 types. Type 1 is in your DNA. It's genetic, and you get it from mom and dad. You don't have any choice in the matter. Type 2, on the other hand, would be acquired. That's where you have a bad diet, maybe you don't eat right, and your appendix shuts down and it can't regulate your blood sugar. So, looking at this, dad has diabetes, mom does not. Well, as you can imagine, because you get some of your DNA from dad and some of your DNA from mom, some of their kids have it, right? Half of the kids, 3 of the 6. Well, that makes sense, 50%, right? Doesn't have to be 50% though, but it is here. Half the kids get diabetes, the other half don't have it. So let's go ahead and look over here at the right. So this daughter, does she have diabetes? Yes, she does. She has that blue color. She marries a man. Does he have diabetes? No. So they have kids. And once again, as you might imagine, some of their kids can have it and some of them can't. In this case, only one of the children ends up getting diabetes. So let's look at this daughter here. Does she have diabetes? No. Does her husband? No. Oh, great. Neither mom or dad have diabetes. So you might think, well, since neither mom or dad have it, they certainly can't pass it on, right? Well, as you can see here, when they have kids, how many of their kids end up with diabetes? It's still half, right? 2 out of the 4 still end up with the diabetes. And so this shows us that even though they don't have the disease, you can still be carrying the disease in your DNA. Remember how when we mentioned hair color, we said you may not have the same hair color as mom or dad. And that's okay. You still got it from mom and dad because they're carrying in their DNA information from your whole family history. So maybe grandma and grandpa had the hair color, or maybe great grandma, great grandpa. Let's go over here to this side. So once again, here's the son. Does he have diabetes? No, he doesn't. Does his wife? No. So, but we know that this can skip a generation, right? We saw that already. So we know, okay, one of their kids ends up getting it. So let's go down to here. Does this son have diabetes? How about his wife? Neither of them do. So now it's been 2 generations. And you might think it's gone by now, surely. But it's not. It can still show up. Things can be hidden in your DNA for several generations. Now, if it's been, 5 or 6 generations since you've seen that trait, maybe it's gone by now. It could have filtered out at some point and not been passed on. But it could be reintroduced, of course. So that's just showing us that you are carrying more information than what you necessarily have. Please pause and write this. And I do need you to do this little diagram at the bottom, please. So pause, write the bullet point gene, and then do this little diagram as well and label the parts. Pause now. All right. So hopefully now everybody has gotten that written down. So we're going to talk about genes for a few minutes. A gene is one piece of the DNA strand. So here's a DNA strand. Here's another picture of it. If you've ever seen this, it's like a ladder that you've twisted. This is called a double helix. It's like a ladder that's twisted up, right? That's what your DNA looks like. So if you look in a cell, we know that in a eukaryotic cell, the DNA is wound up. And it's these little bundles called chromosomes. If you've ever taken a piece of string, like a thread, and you've wrapped it up in your finger and get a little ball of string, that's what a chromosome is, right? It's just a little wound up ball or this X of DNA. So if you unwind that, well, you're eventually going to get to this little DNA strand. We're zooming in here at that DNA strand. It's very long and very thin, and it's in your DNA. These little bundles called chromosomes. Well, one little piece, one tiny little section of that DNA strand is called a gene. And those genes could be short, they could be longer, it just depends. Every gene can be different. You can have really short ones, really long ones, etc. And they all line up together, and that makes your DNA strand. So maybe this gene right here is the gene for your hair color. And the one next to it maybe is for whether your hair will be curly or straight. And the gene over here is for how tall you are, or you will be when you're an adult. And you line up, you connect all those genes together, and you get your long DNA strand. That's what a gene is. One piece of the DNA strand, a code for one inherited trait. Every gene equals one inherited trait. And as you can see here, we write a gene, or we can write a gene with 2 letters, and we can have something called dominant or strong alleles and recessive alleles. But we'll talk about that when I get back after Thanksgiving break. Let me have you write down just a couple more things here. So please pause the video here and skip a line and write these 2 bullet points, and again, indent if I indent. Do that now. So you've written those down. The dominant trait is the stronger trait, and a recessive trait is a weaker trait. And again, we'll talk more about this when I return. But a good example of this is your ears. Look at the ear up top. See how it dangles down and it hangs below? Most of you probably have ears like this. Raise your hand. I know I can't see it, but the substitute will see it, and their classmates will see it. Raise your hand if your ears dangle down. They have a lobe at the bottom that hangs down a little bit. As you look around, you should see that that is the vast majority of people in the class. Now, raise your hand if your ears don't dangle at all. They just attach at the bottom. Look at my ears here. I don't know if you can see it. I'm going to put it up to the camera there. Probably can't see it because it's so small. But my ears, as you can see, do not dangle at all. They attach right to my head. That is rare. That doesn't happen very often. Raise your hand if you have that. I bet there's maybe one or maybe two people in the class, probably, I'm just guessing, who have that. It's rare because it's weak, it's recessive. It's only expressed if the dangly gene or the dangly allele is not there. We'll talk again about that later. Please stop, pause, and write this. And please pause and write this. And we'll save the last bullet point for another time. All right. Thank you, guys. Hopefully you have this in your notes. If you didn't get it, these notes are still posted up on Google Classroom, and so you can find them there. All right. Have a good Thanksgiving, everybody, and make sure you're good for the substitute for the rest of the time, and I will talk to you later.